Now members, today we are back with our chemistry, that is O-level chemistry, and our area of concern today we are going to look at what we call electrolysis. Electrolysis is one of the topics which is applied more in most areas of the world and is very, very vital. However, we are going to begin by getting our definition here as a writing there, and we are going to define electrolysis as simply the decomposition of a chemical substance which we are calling electrolyte by passing electric current. People can define it differently. However, what matters is the word decomposition of an electrolyte by passing electric current. Now, after defining, we are seeing that we are introducing an electrolyte in our definition. So we have to also define the electrolyte. Electrolyte is something simple. It's simply any chemical substance that can conduct electric current in molten state. Molten state is the same as aqueous state, or it is the same as solution state. It can be solution state. Here we can use an example like we can look at water. Water is an electrolyte because it can allow current to pass. You have ever seen when you put a wire of electricity in water? Again, when you touch that water, you will see that you are going to become electrocuted. But again, if it was cooking oil cannot do the same work, cannot allow the current to pass. Therefore, now the cooking oil, diesel, paraffin, petrol, and others are going to be under non-electrolytes. Simple organic substances will fall under non-electrolytes. So, non-electrolytes are the opposite of electrolytes. These are simple chemical substances that do not conduct electric current in molten state. I've already given you examples, like when you look at ethanol. Ethanol is one example. You look at cooking oil, most organic substances, and so on. Now, from there, after understanding the difference between the electrolyte and non-electrolyte, members don't confuse these ones with what we call insulators and conductors. Conductors, for them, they are conducting but in a solid state. Then insulators, those ones are not conducting but in a solid state. Take an example, rubber, then dry wood, those ones are falling under insulators. But again, when you come to conductors, you can look at, like, for example, copper wire, aluminium wire. Those ones now will become neighbors of electrolytes and non-electrolytes, but in a solid a solid state. Now, the big question is going to be, how do electrolytes conduct? Now, our main emphasis now on the conductivity of the electrolytes, we shall put our emphasis on what we call the free mobile ions. These free mobile ions are very, very vital. An electrolyte can conduct because of the ability of that electrolyte to break down or to dissociate to form what we call the positively charged ions, which we are calling the cations, and then the negatively charged ions, which we are calling the anions. Now, remember, even in the solid state, the cations and anions are there. But what matters, the force holding now those cations and anions in the solid state are stronger. How would you weaken them? You weaken them by heating, by putting in solution state. So, what we can say, heating, here when you heat the sample, or when you put in a solution state, you'll weaken the forces of attraction, and then you'll find that there will be now the breakdown of the forces to release what we call the free mobile ions. These ions, we have said, cations and anions. Now, these ones we shall see that as we are moving on, the anions are going to become oxidized. They undergo oxidation. They are giving away electrons. Then the cations will undergo reduction, gaining electrons. So in the process of oxidation and reduction, we shall see conductivity taking place. So when they ask you, why is it that solid sodium chloride does not conduct, while molten sodium chloride conduct, you are going to dwell more on the free mobile ions. That in a solid state, the cations and anions are not free. They are being held by strong forces of attraction. But again, in the molten state, it is conducting because the cations and the anions are free because of the forces holding them being broken down by heating or by dissolving in water. Now from there we go to the point of defining our anion. Anion, to simplify the work, members, anions are simply the negatively charged ions. We can give, for example, the hydroxide, then you can even give the chloride ion. Then when you come to cations, cations are simply those ions which are positively charged. So for example, copper. Okay, members, we are defining our anion as a negative ion, and we are giving example of hydroxide, chloride, you can have bromide, iodide, and so on. Then our cation is positive ion, so we can talk about copper, silver, sodium, calcium, magnesium, and so on. Now when you come to these ions, now are going to migrate towards terminals, which we are calling the electrodes. So we have two types of electrodes. We have what we call the cathode, and then we have what we call the anode. Now the difference in these two terminals, or the poles, the cathode pole or terminal is negative. And being negative, we always see that it is a point where we are going to gain the electrons, what we are calling it reduction. We are gaining electrons at the cathode. Then when you come at the anode point, the terminal is positive. Terminal being positive, it means that the electrons are going to be lost at that point. So this implies that at the anode, we are seeing oxidation taking what? Oxidation taking place. So we are going to see it as we are moving on with the other parts. Now, so the equation can come saying define an electrode. This one is going to be a terminal or a pole where current enters or leaves the what? The circuit. But remember, we are saying we have two terminals, the cathode and the anode. Anode positive and the cathode being negative. So now we are seeing here, we are specifying that cathode receives the positive ions. Remember, the positive ions are our cations here, which we talked about. Our positive ions are cations. Where are they going? They are going at the cathode. Then the anode is receiving the negative ions. Our negative ions are anions. We are going to reach somewhere there. We are going to talk about oxidation, which is being done by the negative ions. Occurring where? Occurring at the what? At the anode. Now from there, now we are seeing that our positive ions, which we are calling anions, are losing electrons. We are seeing that our positive ions are going to move to what? Cathode. Then our negative ions are going to move to the anode. So this implies that our negative ions are going to lose the electrons. And as they are losing the electrons, there we shall see oxidation is taking place. For example, you are having the hydroxyl ions here. When you look at them, they are losing the electrons which I'm talking about. You can see some loss of electrons there. So we are losing electrons here. You can see these electrons being lost. And that one now we shall see that this is oxidation. This is oxidation. Oxidation taking place where? Taking place at the anode. But is being fueled by what? By an ion. So we are seeing an ion, anode, oxidation. Those ones are brothers and sisters. Anode, then an ion, then oxidation. Then when we come to the cathode, we are seeing positive ions going there, which we call the cations. Take an example, you have sodium, and we are saying you are gaining. You can see you are adding an electron there, you are gaining. When you are putting on the right hand side, you are losing an electron. If you are going to lose an electron but you are putting it to the left hand side, you will put minus electrons. But here we are putting plus for electrons, losing them. But here we are putting them on the left hand side. Left hand side means you are gaining. Right hand side means you are losing. So if you are going to change the hands, it means you will change even the charge somewhere. Now, you can look at our copper is also gaining 2 electrons to form the copper solid, and our lead ion is gaining 2 electrons. But all of these ones are taking place where? They are taking place at the cathode. Which cathode we are saying is a negative terminal. So, from that point of view now we are seeing that the cathode is having what we are calling the cations, and we are having our reduction there. So as we say that with the anode, we have oxidation, we have anions, then we have what you call oxidation there. Then when you come to our cathode here, we are saying we have the positive ions, the cations, then we are having reductions. So cathode, cation, reduction. Those are brothers and sisters. Then with anode, we are saying anion, oxidation, anode, and so on. So let us try to move ahead. So you are saying electrons flow from the anode to the cathode. That one we have to take note as we are moving to our diagrams there. The electrons are going to flow from the anode to the cathode. Why? They are being produced at the anode by oxidation. Then they move to the cathode. Somewhere question will ask you to put the arrow showing the flow of the electrons. Now, they are saying, when does the ion become discharged? Discharged means when does the ion become selected? Members, we are looking at the factors which now can determine the discharge of the ion, and then we are seeing that one of them should be the position of the ion in the reactivity series. Now we are seeing that if the ion is appearing lower, the chances of it being discharged are higher. But if it's appearing higher in activity series, the chances of being discharged are going to be lower. This one can give an example. For example, when you are going to carry out electrolysis now of sodium chloride. When you are carrying out electrolysis of sodium chloride, you will discover that we shall be having the sodium ions. We shall be having the sodium ions. Then we shall be having even the chloride ions, and then the hydroxyl ions, and then the hydrogen ions. Now we are going to discover that we have two positive ions there. Now they are competing for the other terminal, the terminals we talked about, the cathode and the anode. So now here we are going to look at the position. The arrangement is like this, as I'm showing you here. You can look at that arrangement like that now. This implies that when you come to arrangement, you check where sodium is. Sodium is here, and then hydrogen is here. Now this implies that hydrogen is appearing lower, and if it is lower, it stands high chances of being discharged, and the sodium which is appearing higher. So this order you have to master it properly, of the reactivity series. For anions, the story is going to be the same. You discover that now we have hydroxyl ions, and then we have chloride ions. Now our argument will be the hydroxyl ions and the chloride ions, which ones are appearing lower. You discover the hydroxyl ions are appearing lower. So if you have chloride ions and hydroxyl ions, these ones are going to be discharged. The chance is higher of being discharged in preference to the other ones. Why? They are low. These ones are higher. The more you are higher, the lower your chances. The more you are lower, the higher your chances of being discharged. So one of the factor, that is the position. Now the second factor is the concentration. This factor here of concentration. The more the ion becomes highly concentrated, the higher its chances of being what? Discharged. We can use an example. See, if you are going to carry out electrolysis of sodium chloride, concentrated sodium chloride, blind, you'll find that the number of sodium ions and the chloride ions in the brine or the concentrated sodium chloride are going to be higher. So this implies that you are going to discharge the sodium ions and the chloride what? The chloride ions. Then when you are carrying out electrolysis of dilute sodium chloride, you'll discover that now you're not going to discharge the sodium ions and the chloride ion. Instead, you are going to discharge other ions, as we are going to see. Then the other factor is going to be nature of the electrodes. Nature of the electrodes always determines which ion is going to be discharged. Now we are saying here it influences the ion to be discharged. This one is observed like when you are carrying out electrolysis of copper to sulfate. Some we are going to see as we are moving ahead. We can use the copper electrodes, or we can even use carbon or platinum electrodes or graphite. Now when you are using copper electrodes, you will find different products formed. But again, when you are forming carbon electrodes, you are using carbon electrodes or graphite electrodes or platinum, you will find that other products are going to be formed. Meaning the ion is discharged when you are using copper electrodes, and when you are using graphite electrodes are not the what? Are not the same. You are going to follow me up as you are going to see that one in front there on the diagrams. So members, to harmonize the factors, we have three factors. Position of the ion in the activity cell. We are repeating that the higher the higher the ion in the activated cell, the lower the chances of that ion to be discharged. And the lower in the activity cell, the higher the chances. Then the second factor was concentration. Concentration. We are saying the higher the concentration of the ion, is always the higher the chances of the ion to be discharged. Remember, discharging we are meaning migrating to a particular terminal. Which terminal we said it can be positive, that is the anode, and it can be negative, that is the what? The cathode. But don't forget that the cathode we are taking there positive ions, cations. And at the anode we are taking there negative ions, the anions. And the anode we said there is oxidation. At the cathode there is reduction. Oxidation you are losing electrons. Reduction you are gaining electrons. So now after understanding these factors, let us try to go to the questions which are always common for the areas which are always. Now members, we are looking at the electrolysis of individual electrolytes. And now our first electrolyte is sulfuric acid. Sulfuric acid in this cell we are using what we call electrolytic cell. Electrolytic cell must be having what we call the anode and the cathode. How do you tell the anode and the cathode? You tell the anode by basing on the connection which they have done. Take an example here. They are connecting the positive terminal of a dry cell to this terminal here, meaning positive moves with the positive. So this one becomes a positive terminal as an anode. Then this one we are seeing a negative terminal. The shorter bar is for negative of a dry cell. Then the longer bar is a positive of a dry cell. So now a negative, which is a short bar of a dry cell, is going to be connected to the cathode. So we shall have our cathode there. So this is cathode, this is anode, but we are based on the terminals. Now we have put sulfuric acid in our cell here. When we put sulfuric acid in our cell, now we are going to see it breaking down. Remember electrolysis, we are referring to the decomposition. So now we are having now sulfuric acid breaking down. When the sulfuric acid is breaking down, we are saying sulfuric acid is going to release hydrogen ions and sulfate ions. But at the same time, there is some water because it is a solution. So we have our water also breaking down. When the water breaks down, we get hydrogen ions as well as hydroxide ions. Now our puzzle is that we have the ion. We have two types of ions. We have those ones which are positively charged. The hydrogen, those ones have no problem because they are similar. But again, we have the negative ones. We have the hydroxide ions which are negative and the sulfate ions which are negative. Now, we want to see that now the positive ones are going to move directly to the cathode. So we are seeing them moving the cathode here. Then the negative ones, we have the hydroxide ion and then the sulfate ions. Now these ones, because two of them are negative, we want to check which one will go. How do you know? We go to the factors. Now here the factor will be the factor of the position in activity cell. We come and we check the sulfate and the hydroxide, which one is lower than the other in activity cell. You discover the hydroxide is lower than the sulfate in activity what? Activity cell. So there we are applying a factor of the position in the activity cell. Now we come and then we take this one to be discharged. So when we discharge it, we shall take this one there to our anode there. Now when we put it there, we are going to see what we call oxidation. So this one, we will form water plus some oxygen, then plus some electrons. And before electrons to balance the equation. Remember, we have left the sulfate, not that we don't want it. The reason why we are leaving it has been higher in the activity cell. We said you are higher, we leave with you behind. Then we go with the one who is lower. Now, when you lose the electrons we have lost here at the anode are the electrons which the other species at the cathode is going to gain. So we shall find out gaining electron there at the cathode by the hydrogen which came from sulfuric acid, and here we are going to obtain what we call hydrogen gas. We have hydrogen gas there, and then to balance the equation it means we are going to put a 2 there, and the electron is also going to become what? Become 2. So we have formed two gases. We have formed a gas for oxygen and a gas for hydrogen. Now, when we come back to our diagram where we are putting the gas now, the gas, it means the gas at the cathode here, the gas at the cathode, we are having our hydrogen what? Hydrogen gas at the cathode. Then at the anode, our gas here we are talking about, we are going to be with what we call oxygen gas. So we have two gases, oxygen at the anode and hydrogen at at the cathode. Now, another point will be now, what the question can say, what is the observation if you put litmus paper here? Remember, the more you remove protons or the hydrogen ions to form hydrogen gas, acidity will lower. So when you put now the litmus paper, previously before the electrolysis is taking place, you found the litmus paper was turning purely what? Purely red. But now when you are carrying out electrolysis, when you are removing hydrogen ions and you are reducing acidity, the paper will pink. We can say it can turn pink, or sometimes if you take a longer time when you are carrying out electrolysis, it can even remain what? Blue. So we are seeing the blue paper turning what? To pink. That is if there is some little hydrogen ions. If they are not there, it's going to remain what? Remain blue. Then from there, they can ask you how you can identify this gas here at the anode. That one is by using a glowing spirit, which is lighted. Then for the one at the cathode, that is hydrogen, that is by using a burning spirit. Then you remember what we call the pop sound. When you are putting a burning spirit, the gas jabbing this one and oxygen, so we shall get our what we call pop sound. So observation at the anode, colorless gas. Then observation at the cathode is still colorless gas. And that is now what we can talk about, that electrolysis now. Now, secondly, we can talk about electrolysis of copper to sulfate. This electrolysis of copper to sulfate, we can do it in two ways. One, we can carry it out by using copper electrodes. Or we can carry it out by using other electrodes like graphite electrodes. We can talk about graphite electrodes, these ones here. We have that one. Remember, this is copper to sulfate, and even this one is copper to sulfate. But the difference is that we are carrying out electrolysis using copper electrodes here, and here we are going to use graphite electrodes. Now, what happens here? Let us first begin with the knowledge of determining which one is the anode. So you can see this is a negative terminal of our dry cell. We said negative is going to a negative, meaning this is a negative, and this one is going to become our cathode. Don't forget that. And this one we are seeing is the longer bar is going where? Is going to the anode. And this implies that this is our anode. Remember, anode receives what? Anode receives the negative. The anode is going to receive the negative ions. Here we shall get the negative ions here surrounding. And here we shall get positive ions surrounding. It is the opposite. So now we have our copper to sulfate being electrolyzed. But we are using the impure copper. Actually, this one we are using it in refining copper refining. We can apply it there. So we have here copper. Here, beg your pardon, is going to be of copper. And even this cathode here we have is going to be of what? Of copper. So we have two copper. The difference is that this copper, this side is pure, and this copper is what? Is impure. Now, what we are going to see this time now, we are going to see now our copper impure, this side of the anode dissolving now. We shall have our copper anode dissolving to form what we call copper 2 ions. Copper 2 ions plus 2 electrons. Now the observation will be now this one is disappearing. Lowers in mass, reduces in mass. This one here, the anode. Then at the cathode, the electrons we have lost there. Remember this one here. The copper 2 sulfate is producing copper 2 ions. Copper 2 sulfate is breaking down to form copper 2 ions. Don't forget that. Plus sulfate ions. Now our area of concern is on the copper 2 ions. So copper 2 ions, they are not competing with other ions. They are only positively charged. So here what are we going to take? We are going to take now our copper 2 ions here from the copper 2 sulfate, and then they are gaining electrons, 2 electrons, and we are going to form copper solid, which is pure. Meaning, at the end of the experiment, as this one is reducing in the mass is increasing on this one. We are seeing more copper coating here. Therefore, the cathode is increasing in the size. Now, remember, as we are saying, our observation is here that our anode is going to reduce in mass, or we are saying the size. Remember now here we are applying a factor for nature of electrodes. the graphite or carbon electrodes is going to be different from this one we are getting here. So we have that factor of nature of electrodes. Now, what is going to appear the color of the copper 2 sulfate? That is in the solution. Remember, it is the pale blue here. So here, previously, we had the pale blue. This is pale blue. So what are we going to see? We are going to see here that the pale blue solution turns to a colorless what? Turns to a colorless solution. That one is as a result of discharging the copper 2 ions. As we are removing these copper 2 ions to form the copper solid, this pale blue, our pale blue here will reduce slowly. So they can ask you those observations. Take a note of that. Now, members, we have seen this one. We have been using copper electrodes only. Now we are going to use copper cathode. But again, the anode we are going to use is going to be for carbon or graphite or platinum. So, remember now, if for example we are illustrating, let me try to sketch here a bit. Now we have here, if this one, our cathode is remaining as it was, that is for copper, then this one is becoming our carbon. It can even be graphite. It can even be platinum. Then we connect our circuit like that. This is our, remember, our anode, and this one is our cathode. This is what we want to look at. Then now this one is shorter. We said negative terminal go to negative terminal. Then the positive terminal go to positive terminal. Then from there now, what we are having there, here we are having our electrolyte, which is for copper 2. Now this one is going to touch there like that. Then now from there, what are we going to see? What we are going to see, of course, the ions are there. Our ions, we have the copper 2 ions. We have the sulfate ions. We have the hydrogen ions. And we have even the hydroxyl ions. Remember, these ones are coming from water. Hydroxyl ion is negatively charged from water. This one is from water. This is from electrolyte. And even that one from electrolyte. Now, what are we going to see there? We want to see which one is going to migrate. Now, in this case, now we are going to move back to where we said. You have hydroxyl, you have sulfate. Now, negative. So we check which one is lower. We go back to the other point of preferential discharge. So when we go back here, we said the hydroxyl is lower than the sulfate. So we shall find our hydroxyl here, in this case, going. So where there is anode, we shall still take our hydroxyl like that. Have our hydroxyl, which is going out to produce our water plus some oxygen plus some electrons like that. Hope you can see. But again now, you look at the ions which are present. We have the copper 2 ions and hydrogen ions. Copper 2 ions and hydrogen what? Ions. We are going to go back still here and we ask ourselves that copper and hydrogen, which one is higher? We are going to discover that copper is lower than hydrogen. So if copper is lower than hydrogen, we said the lower one will go. So we have copper 2 ions plus 2 electrons, which came from the anode. They are flowing from the anode to the cathode. Don't forget that we said the electrons move from the anode to the cathode. So there we shall form our copper solid. This implies that even this one, the cathode is going to become coated with what? With the copper. So the mass will increase. But this time the copper is not the other copper, which was dissolving from the anode as we observed here. So here our copper is as a result of the copper 2 ions which are being discharged now, and then the mass here increases. So our observation here, the size or the mass of the cathode increases. But this one doesn't change. The graphite or the carbon remains unchanged. But still here the solution is going to fade. It's going to fade from pale blue and then finally to colorless. So try to look at this idea and then this idea. Here we are considering the factor of the nature of the electrodes. Nature of electrodes, here we are using carbon and then copper. Here we are using copper, and so on. Now let us try to move a step to what we call electrolysis of blood. Now this is concentrated sodium chloride. Concentrated sodium chloride, we are going to bring in a factor of concentration. Here we have the factor of concentration. How many ions are present? So now we have our sodium chloride as an electrolyte, and if you have sodium chloride as electrolyte, we are seeing our sodium chloride is going to break it down to form the sodium ions plus again the chloride what? That's the chloride ions. You can look at that like that. Now we are seeing that the sodium ions and the chloride ions are highly concentrated. So what we are going to see here, our sodium ions are going to migrate to the anode. Migrating, they are going to be discharged. And then our chloride ions are going to move to the negative terminal or electrode. So this one, when they go there, they lose the electrons. As they are losing electrons, they... Yeah. Now at our anode, we are seeing that we have the chloride ions. Chloride ions are being discharged to form the chlorine gas plus the electrons here. So we have electrons, these are our electrons, plus our chlorine gas, and so on. Now the electrons which we have lost here, let me make them clear. The electrons we have lost here. Now we can balance the electrons by putting the two actually here to make the thing clear. Now from there, the electron which you have lost there is going now to move from the anode to the cathode. When it goes to the cathode, after losing the electrons here, as you have seen, the electrons now are going now to be used at the cathode, meaning electrons will move from the anode to the cathode. So we are seeing the sodium ions now getting the electron then to form the sodium solid. So this one we are calling it reduction. Don't forget that. That is our reduction. As this one we are calling it oxidation. Now from there we are seeing another question. We are saying indicate the flow of electrons and the current. On our diagram here we said electrons are flowing from the anode, don't forget that, to the cathode. So we first check our anode, it is where. How do you follow up the anode? By looking at the longer bar here of the battery, or if there is a voltmeter, you look at the positive side. So this one becomes our anode. Members, don't forget that. It's our anode, which can be graphite anode or carbon anode. Then this side now we are having a short bar which is a negative, is attached to a negative. So this is a negative and this is a positive. So this one is our cathode. Our cathode there. So meaning the flow of electron will be like that. Electrons are going to flow like that from the anode towards the cathode. Then the current, as the electrons are flowing, the cathode current is flowing oppositely to the flow of electrons. So we are seeing the electrons flowing from the anode to the cathode, and this one is current now. This is our current. So we are having our electrons from the anode to the cathode. Then we have our current from the cathode to the anode. As simple as that. So what happens in the bulb when you complete the circuit? This bulb is going to give off light. Gives off light. Meaning we have light. You complete the what? The circuit. Now from there we can move downwards to electrolysis of diluting sodium chloride. Now remember, the factor here we are looking at the factor of concentration. This one has been concentrated sodium chloride, which we are calling blood. Now we are looking at diluted sodium chloride. So diluted sodium chloride, it means we have our water there. Water is excess, so and the water is breaking down to give us our hydrogen ions and our hydroxyl what? Our hydroxyl ions. Don't forget that. Then at the same time, even the sodium chloride is breaking down to form the sodium ions plus the chloride ions, like that. Now this implies that we have 4 ions there, 2 positive ones and then 2 negative ones. Now what is going to move to the anode? We are going to bring in which one is highly concentrated now. We are going to see that now, because water is excess because of the word dilute. Water is a lot, dilute sodium chloride. So this implies that now the hydrogen ions are highly concentrated. Even the hydroxyl ions are highly concentrated than the chloride. These ones are more than the sodium. So at the anode, we are going to take these ones, hydroxyls, which are highly concentrated. They become discharged. So when they become discharged, don't forget we get water plus what? Oxygen plus our 4 electrons. We balance it like that. Our gas like that. Then at the cathode, of course, electrons which you have lost here by oxidation, you are going to gain them. So the hydrogen ions will gain the electrons we have lost there to form again what we call the hydrogen what? Hydrogen gas. So our observation now, this one is at the cathode now. Don't forget. Let me squeeze it here. That is the cathode. This is anode. Anode, you are losing electrons with production of oxygen gas. That is observation at the anode. The observation at the cathode, that is also hydrogen gas. Colorless gas, colorless gas. But this one, the light is a glowing spirit. This one produces pop sound when a burning spirit is lowered in a gas jar having oxygen and the hydrogen gas. So members, let us wrap up the whole story by looking at the application of electrolysis. Electrolysis is very, very important in what? Our daily life. So we are seeing that electrolysis is used in electroplating. You always see your folks at home, silvery, you always see iron sheets being coated with other metals, what we are calling electroplating. That is one of the applications of electrolysis. Electroplating, we can demonstrate it properly by applying this image here, or this diagram. Electroplating, you are covering one metal to another metal. So for instance here, we have silver, and then we have a metal which we don't know. You can even put there a fork, or you can put there even a panga or a knife, this side. Now you have a silver anode, and then you have the silver anode being dipped in silver nitrate solution. Now what we are going to see, anode is going to dissolve. As it dissolving, is going to be coating the other side. But how? The idea is going to be that now we have our silver, meaning this one is going to become our anode. Don't forget, our anode and the other our cathode. So what is going to happen here? Our silver is going to dissolve to form. Our silver is going to dissolve to form silver ions plus electrons. Then the electrons which you have now lost there, what happens there? Ions now, after being formed, then we have our electron. Now we are having the silver ions still in the solution. This is now our anode. Equation at the anode. That is the reaction at the anode. Now at our cathode, we are seeing the silver ions are going to receive the electrons to form silver. Now the silver, remember the silver ions have been around here, everywhere. Now they are forming the silver. The silver is going to cover here. The section is why we are seeing the silver is reducing. The silver anode here is reducing in size. You can see. Size is reducing, and this one is increasing. Why is this one increasing? Because of the coating of the silver, which silver has been formed at the point of the cathode here. The silver is going to coat now the other side. If we had the fork here, take an example, if I'm to illustrate here, and you had the fork, for example, the fork we are using at home, this fork will be coated with what? With the silver. Even if it was from aluminium, now we shall see the coating of silver along with the what? Along with the fork. Even if it was a panga, it will become now silver. So that's why we are putting here the cathode being coated with the silver, or become having silver what? Deposits. That one we are calling electroplating. This one has been cathode, anode. And what has happened? You have coated the silver on the what? On the cathode. Then from there, another application, we have what we call manufacture of sodium hydroxide. This one we are using what we call the mercury cathode what? Mercury cathode cell. And we are putting there the brine. What happens there? Our brine breaks down. When the brine breaks down, we form the sodium ions plus the chloride what? The chloride ions. Now, at the anode, what are we going to see? The chloride ions now are going to lose the electrons to form chlorine gas, like that. Chlorine gas, and our 2 electrons there. Chlorine gas will be given off. Then at the same time, at the cathode, we are seeing the sodium ions will get the electrons and they form the sodium what? The sodium solid. Now the sodium which has been formed, this is the mercury cathode cells having a cathode made up of what? Of mercury. So we are seeing that our sodium formed will combine with the mercury, which is a liquid, to form what we call the sodium amalgam now. Now the sodium amalgam will combine with water again. We are going to see that the sodium amalgam combined with the water, because the cell is having some shells with the water, and to form what we call the sodium hydroxide, which we want, plus hydrogen gas, and then we regenerate our what? Our mercury. So the story is going to be like that. So from there, now our major emphasis was at manufacturing sodium hydroxide. This is by electrolysis. This one can occur in mercury cathode cell or castenase cell. Then finally, the other application which is important is what we are calling copper refining. This one already we observed it before, but let us try to emphasize it here. Here we are purifying impure copper. But how are we purifying impure copper? You make impure copper the anode and the pure copper the cathode. Now what happens here, you are using an electrolyte of copper to sulfate. So what happens, we are going to see that our impure copper, which is the anode, is going to dissolve. Our anode is going to dissolve. When it is dissolving, it's going to form what we call copper 2 ions plus 2 electrons.